Hey there, let's talk about a core math concept that, believe it or not, you use every single day, probably without even realizing it. It's called set operations. And this isn't just for, mental puzzles. This is the actual logic that powers stuff like search engines and even your music recommendations. So, let's dive in.
Yeah, I know what you're thinking. My friends in math? What's the connection? Well, just picture your friend groups for a second. You've probably got different circles, right? Maybe you have your friends you play football with, and then you have your friends you study with. And that's it. The way you naturally sort those groups in your head is exactly how mathematicians think about sets. It all boils down to two key ideas: union and intersection.
Okay, first up, let's talk about bringing everyone to the party. In math, we call this the union of sets. So officially, the union of two sets, and you'll see it represented by this little U symbol, is just a new set you create that has all the things from both original sets. But, and this is the one crucial rule, you only list each thing once even if it showed up in both of the original sets. No duplicates allowed.
Let's make this way more concrete. Imagine we've got two simple sets of numbers. Set A has the numbers 1, 2, and 3, and set B has the numbers 3, 4, and 5. Pretty straightforward, right?
So based on what we just said, what do you think the union of set A and set B is going to be? Take a second to think it through. We need to combine all the numbers, but remember that no repeats rule.
And boom, there's our answer. The set 1, 2, 3, 4, 5. See what happened? Even though the number 3 was in both set A and set B, we only wrote it down one time in our new union set. That's the whole trick.
All right, so if union is about throwing everything into one big pile, our second operation, intersection, is the total opposite. It's all about finding what's in common.
The intersection, and you'll see this marked with an upside-down N symbol, creates a new set that has only the elements that are found in both of the original sets. It's all about that common ground, that overlap.
Okay, let's switch it up from numbers to, fruit. Let's say set P has an apple, a banana, and an orange. Meanwhile, set Q has a banana, a mango, and a grape. So what's the one thing these two sets share?
Yep, the intersection of P and Q is just banana. Why? Because banana is the only piece of fruit that you can find in both set P and set Q. See? This is all about finding just the shared stuff.
Okay, let's put these two ideas right next to each other to really make it click. Using our first number example, the union of A and B was 1, 2, 3, 4, 5. That's everything combined. But the intersection of A and B, that would just be 3, because that's the only number they both had. See the difference? One is everybody in the pool. The other is only what's shared.
Now, talking about sets with numbers and words is fine, but seeing them is so much better. And for that, we have a super simple and kind of famous tool, the Venn diagram.
Oh, you've definitely seen these before. A Venn diagram just uses a couple of overlapping circles to draw a picture of how sets are related. Each circle is its own set.
And here is where it all makes perfect sense. That little section in the middle, the part where the two circles overlap, that right there is the intersection. It's the little zone where elements, like our number 3, belong to both sets at the exact same time.
And then, if you look at the entire area covered by both circles all together, the whole shape, that represents the union. It's the perfect visual for showing every single element from both sets all scooped up together.
So, what's the big picture here? Let's boil this all down and lock in the main takeaway.
Honestly, if you can just remember these 3 things, you've totally got it. Union, with that U symbol, combines everything. Intersection, with the N symbol, finds only what's common. And Venn diagrams? Well, they're your best friend for actually seeing how it all works.
So, I'll leave you with a final little challenge. Think about your top 5 favorite movies, and then think about your best friend's top 5. What's the intersection? Which movies would land in that little overlapping part of your Venn diagram? It's a pretty fun way to see this math at work in your everyday life. Thanks for tuning in to this explainer.